Welcome to session. Today we'll discuss mensuration. So the first structure is a solid cylinder. If you focus on screen, you can see a solid cylinder with radius r. Okay, so this is the radius r from the center of the cylinder. Then this is the height of the cylinder. It is denoted by h. Now, what would be the area of this top surface, this top circle, what would be the area? Because r is the radius, pi r square would be the area of this top circle. Now, to generate volume of this solid cylinder, we need to stack infinitesimally thin such circles and stack them one above another to build the height h. That means pi r square, this area, you have to stack one above another like this, 1, 2, until you build the height of the cylinder. Therefore, the volume of the solid cylinder is given as area, cross-sectional area, pi r square, and h would be the height. So pi r square h would be the volume of the cylinder. Okay. Now, suppose I cut the surface of the cylinder here and spread it. So when I spread it, it forms a rectangle as shown on the screen now. So here, if I call this length of this rectangle would be the circumference of this circle. That is, when r is the radius, circumference of a circle is 2 pi r. Then the height of the cylinder would be the breadth of this rectangle. So area of this rectangle is given by length into breadth. 2 pi r is the length and h would be the breadth. So 2 pi r h would be the area of this rectangle, which is curved surface area. So remember, curved surface area doesn't include the area of top circle and bottom circle. When we call curved surface area, only this area, that is the area which is curved on the cylinder, only this area is involved. Okay, and that is given by the circumference of this circle 2 pi r and height of this cylinder h. So curved surface area is given by 2 pi r h. Now, to the curved surface area, if I include the top circle area and the bottom circle area, then I get total surface area. So this is the curved surface area. If I include the area of top circle and bottom circle, I get total surface area. So top circle, the area we have seen pi r square is the top circle area. Bottom circle, another pi r square. So top circle and bottom circle for total surface area, curved surface area plus top circle area plus bottom circle area. Curved surface area we have seen circumference of the circle into height of the cylinder, curved surface area. Then top circle area pi r square and another pi r square for bottom circle area. So when you add this 2 pi r square, it becomes 2 pi r square. So if I take out 2 pi r as a common factor, then h plus r. So this is an expression for total surface area of a solid cylinder. So we need to remember three formulae in solid cylinder. One is volume, which is given as circumference. Volume is given as the area of the bottom circle or top circle into height, that is pi r square into h. That gives you volume. Then curved surface area, circumference of bottom circle, that is 2 pi r, and then height of the cylinder. 2 pi r h would give you curved surface area. Total surface area, we need to include top circle area and bottom circle area, that is circumference 2 pi r into h plus radius. So this h plus another this radius. Okay, so the three formula that you need to remember is, figuratively you should remember, don't merely mug up. If you understand the logic behind it and peg it in your mind figuratively, you can recall. So volume would be pi r square h, curved surface area would be 2 pi r h, total surface area would be 2 pi r into r plus h. Clear? Let's move on to hollow cylinder. When we extend the same logic to a hollow cylinder, focus on the screen. This is your hollow cylinder. Here if you see, there the cylinder is hollow in the center along the axis. That means the cylinder has an external radius capital R and an internal radius small r. Then height of the cylinder as usual is h. Okay. So here, what would be the cross sectional area or the top ring circle area? The external, using external radius, we can get pi r square is the external circle area. Internal circle hollow area would be pi r square. So if I remove, this is the whole area minus, if I remove this white portion, that means when I subtract pi capital R square minus pi small r square, I get the area of cross section of the top ring. Okay. So in this, if I take out pi as common factor, r square minus r square. So this is the area of the top circle. So this is the area of the cross section of hollow cylinder. Pi capital R square minus small r square, where capital R is the external radius and small r is the internal radius. As usual, h is the height. So in order to build the volume of such a cylinder, you need to stack infinitesimally thin such cross-sectional areas all along to build the height h. So figuratively, volume you can remember it as cross-sectional area into h. This gives you the volume of hollow cylinder, where capital R is external radius, small r is internal radius, and h is the height of the cylinder. Okay. Now, in the hollow cylinder, when you say curved surface area, so as we have seen in solid cylinder, this is the curved surface area. Okay, so this is the curved surface. But if you see the white portion, there is also internal curved surface area. Okay, so there is an internal curved surface area also. So whenever we say curved surface area for a hollow cylinder, that means external curved surface area plus internal curved surface area. So when I cut the cylinder vertically and project it, so this would form rectangles. In fact, two rectangles. The darkened purple represents the internal curved surface area and the lightened purple rectangle represents the external curved surface area. So as usual, the circumference of external circle would be given by 2 pi r and the height is h. So 2 pi r h would be the external curved surface area, whereas when you consider internal curved surface area, 2 pi r would be the circumference or the length of dark purple rectangle into h would be the height of the cylinder. So 2 pi small r h would give internal curved surface area. So total curved surface area of hollow cylinder is adding them to. So 2 pi r h plus 2 pi r h. If I take out 2 pi h common, then capital R plus h. So curved surface area formula is 2 pi h into capital R plus small r. Now, if you want to calculate the total surface area, to the curved surface area, you need to add the cross-sectional area of top ring and cross-sectional area of bottom ring. We have already seen the cross-sectional area of top ring is pi capital R square minus r small r square. Similarly, cross-sectional area of bottom ring is pi capital R square minus small r square. So, total surface area is obtained as curved surface area plus top ring area plus bottom ring area. So, curved surface we have seen 2 pi h into capital R plus h. This is curved surface area. Now, this is the top ring area and this is bottom ring area. When we add these two terms, you get 2 pi capital R square minus small r square. Okay, so this r minus r square is in the form of a square minus b square. So I can write it as a plus b and a minus b. So r square minus r square, I can write it as r plus r and r minus r. In these two terms, if I take out 2 pi r plus r as common, you are left with h plus capital R minus r. So this is one way of remembering total surface area, 2 pi capital R plus small r into h plus capital R minus small r. Or when you evaluate, when you multiply the parenthesis, you can also remember it this way: 2 pi into RH capital RH small RH capital R square minus small r square. So these two are the formulae that can give you total surface area of a hollow cylinder. So in a hollow cylinder, what we need to remember is the thickness of the cylinder is given by capital R minus small r. Okay, area of cross section is given as pi capital R square minus small r square. The volume is given as pi capital R square minus small r square into height. Curved surface area is given as 2 pi h r plus r.